All right, welcome back. So up until now, we've done a ton of hard work to try to understand what choices an individual is going to make when faced with a particular budget constraint, right? Given somebody's preferences, given what's feasible, what's their optimal choice. And in a lot of ways, this has been a lot of work for not a ton of payoff, because after doing all of our complex analysis and math, really the conclusion we've come to is that people are going to choose whatever's best for them. So the payoff from this comes from the fact that by understanding in this more granular way what someone's optimal choice is, given their preferences, we can make some predictions about things like how will changes in prices, how will changes in incomes, how will various kinds of subsidy programs affect people's choices, right? And this is going to be really important. If we're a business, we're going to want to know things like how will increasing or decreasing our price affect sales? If we're the government, we might want to know something like, if I subsidize solar panels, how big of a subsidy do I need to increase the number of solar panels sold, right? Or on the other side, if I provide a subsidy for example, if I cut sales taxes for groceries, how much is that going to change the amount of people's budget that they spend on food, right? In other words, what we're going to want to do, the first thing we're going to want to do is figure out how to use our optimization tools to derive people's demand curves, the demand curve of an individual person. So first of all, I want to talk for a minute about what we mean when we write down a demand curve. So let's say, for example, I want to know your demand for housing in Highland Park, right? Or Eagle Rock, or whatever neighborhood Occidental is in. And right, as you might remember from 101 and 102, right? What we mean by a demand curve is essentially a graph that tells you at any particular price, how much will you buy, at some price P, holding everything else constant. And what do we mean by holding everything else constant? We mean, let's imagine, right, that we could freeze your income, freeze the prices of every other good, freeze your preferences, and then adjust prices, right, from some very low level to some very high level, and observe how much housing you buy at each potential price. So when we're solving our optimization problems, right, when we take this holding everything else constant, what this is going to mean is, right, our income, prices of other goods, and preferences. So as a concrete example, right, let's fix these things. Let's say that you were trying to decide how much housing in Highland Park you're likely to demand. Given that you have an income of $1,200 a month, you only spend your money on housing or pupusas, right? And the price of a pupusa, which I'm going to call PF, or price of food, is equal to 2. And you've got preferences over pupusas and housing given by, right, so I'll say housing and food given by the natural log of h plus 2 times the natural log of f, right? We're going to give you Cobb-Douglas utility function, right, as a function of housing and food. And what we want to know is how much h at every price pH, right? This makes sense? If we knew this, we would have your demand curve. So one way to think about this, right, one way to go about this is we could say, well, if we picked some value of pH, right, then we could solve this optimization problem, right? So let's say that we picked, for example, pH equal to 1, right? If we had pH equal to 1, we would have a budget constraint where we could afford up to 1,200 units of housing, right, to 600 units of food, right? And we would have some optimal choice. Which I'm just going to make up, right? Let's say that you would get a 400 square foot apartment and buy 400 pupusas, right? Just making up a number here. And then we could say, okay, well, that's what you would do if the price of housing was 1. How about if price of housing was 2? Right? Then you make some different choice. Maybe now we would say that you're going to buy, let's say, a 250 square foot apartment, right? Get some other number of pupusas. You can have a whole different price, right? We can have a price of housing of say $4 a square foot, right? And have a different choice there. So essentially what we could do, we could consider a bunch of different budget constraints at a bunch of different prices, and we could determine, solving each optimization problem, what your best choice would be at each of these prices, right? Once we solved your optimization problem, given each of these specific budget constraints, right? So, a budget constraint like 1 times h plus 2 times f equals 1200, 2 times h plus 2 times f equals 1200, etc. We could simply take the results of each of these optimization problems and report them on a new graph, right? So we could have p here, we could have h here. We'd say, well, let's see, when p was 1, right, h was 400. So we would put a point in our graph, 1, 400, right, that would correspond to this choice here. Right, we'd say, okay, and when p was 2, right, h was 250. So put a point on our graph, 2 and 250. Right, when p was 4, h was 100. Right, put a point on our graph like this. If we did enough of these, right, if we solved enough optimization problems, we would be able to go from a picture that looks like this to a picture that looks like this. Okay, so how are we going to do this mathematically, right? We're not actually going to solve an infinite number of problems at an infinite number of prices, take the result and report them all over here. Instead, what we're going to do is we're going to solve our optimization problem once using an arbitrary price. So essentially what we're going to do is we're going to say pH just equals pH, and then we're going to solve our optimization problem, leaving pH as a variable, and what that's going to give us is our optimal choice of housing as a function of pH, which is exactly what we want when we draw our demand curve. Right, so we'd say let's maximize our utility, right, given by log h plus 2 log f, subject to our budget constraint, which is going to be, right, pH times h plus 2 times f has to be less than or equal to 1200. Right? How do we solve this thing? Well, we know that these are Cobb-Douglas preferences, right? We don't have any sort of kinks or anything unusual. We know that we can't have a corner solution because if we had no housing or no food, our utility would be negative infinity. So we can just look for an interior solution. So we find our MRS. Right? What's that going to be? Our MRS of housing in terms of housing and food is going to be du dh over du df, right? Du dh is just going to equal 1 over h, and du df is just going to equal 2 over f, right? So our MRS will just equal 1/2 times f over h, right? Cool. Okay, what do we do once we have our MRS? We set it equal to our price ratio, right? So 2 MRS equals price ratio, right? So we'll say 1/2 times f over h equals our price ratio, which is the price of housing over the price of food, which is going to be the price of housing over 2. Right? We can use that to get food in terms of housing. We'll say f is going to equal 2 over 2 times pH times h is just pH times h. Right? And then we plug that into our budget constraint. Right? So we'll say pH times h plus 2 times f, which is pH times h, has to equal 1200. Right? right? This means 3 times pH times H equals 1200. So H is going to equal 1200 over 3 pH, which is just 400 over pH. And that's our conclusion, right? We're going to say that our housing, our demand for housing, as a function of pH, is going to equal 400 over pH. And this is, right, our equation for our demand function. If we want to graph this thing, we're going to end up being able to produce a graph, right, where we'd say, okay, if pH is 1, housing is 400. If pH was 4, housing is 100. pH is 8, right, housing is 50 square feet. And this is exactly what a demand function is. So how we're going to do this, right, just to recap, how we're going to solve for our demand curve is we're just going to solve our optimization problem, but leaving the price of the good in question as a variable, right? And the result of that is going to be, we'll get demand for our good as a function of the good's price. All right, cool. So that's all I'm going to say about individual demand curves. In the next video, I'm going to talk about angle curves.